greater the boiling point or melting point of the substance. So when your polarity is very high, then your boiling point will be high if you are a liquid, or your melting point will be high if you are a solid of the substance. Number 12. Which group of elements form hydroxyl pyramidal in structure? Look at that. Hydride means hydrogen is there. You know, for it to be pyramidal, then you must be group 5. So that is group 5 elements, not group 3, group 5. That's why ammonia like this is a trigonal pyramidal. Ammonia is trigonal pyramidal, group 5. You know, so even phosphine also is trigonal pyramidal, pH3. pH3, phosphine. These guys are in group 3 and they are trigonal pyramidal. And why are they trigonal pyramidal? Because they have a lone pair of electron. Lone pair, they have lone pair of electron here. So that's it. So the answer is group 5. So number 12 is C. 13. Water has a rather high boiling point despite its low molecular mass. It must taught you something like this recently. The reason why some organic compounds have high boiling point because of the presence of hydrogen bonding. So the answer is A, hydrogen bonding. 14. Argon is used in gas-filled electric lamp because it helps to prevent oxidation of the lamp filament. That's it. Because the lamp filament will not be oxidized. Once the guy is oxidized, the filament is gone. The bulb is wasted. You know, so it will prevent oxidation of the lamp filament. 15. So number 14 is B. 15. The air around a petroleum refinery is most likely to contain. Now, don't forget that petroleum is also organic compounds, and Amos explained also that when hydrocarbon, importantly, petroleum is hydrocarbon. When petroleum undergo combustion, they will give you carbon dioxide and water. So the major pollutant in petroleum refinery environment, refinery region, the pollutants, the cocoa of them all is CO2. Remember that the CO2 cover they call the greenhouse effect, global warming, greenhouse effect, GHE, you know, global warming. And that guy is also responsible for flooding, global warming, flooding. So all these are the effects of greenhouse effect. You know, when you have too much of CO2 in the atmosphere, can be dangerous. So the CO2 greenhouse effect is a pollutant. The atmosphere, the earth become warmer, and then it brings about flooding. So CO2 is a major pollutant. So if you don't see CO2 in the option, then you remove that. So option C is out. You don't get CO2. All of them have CO2. Now, another thing that comes from CO2, because of the environment, actually when you don't have complete combustion, you may have CO. CO is a daughter to CO2. You know, anyway, you have CO2. Once you have heavy carbon in that environment, it will reduce the CO2 from heavy carbon by the heavy carbon to CO. So you can have that. So CO2 and CO should be in the option compulsorily. So the answer will definitely be B. That's the only guy that has that. Another one again is nitrogen, oxides of nitrogen. They're also there, oxides of nitrogen. While some petroleum contains some additive, which may include the amines. We can also have oxides of sulfur, you know, and that's what makes the question a bit controversial now. Oxides of sulfur, you can have CO2, SO2. But in that pecking order, this is Olorioko number 1, followed by this, oxides of nitrogen, and then you can have this. So in case you don't have nitrogen oxide, you can have sulfur oxide too. So so their most ideal answer there will be B, most ideal, because CO2 is very important. There's no pollution around the refinery without CO2. 16. Water can be identified by the use of, we mentioned that yesterday, can use copper sulfate or cobalt chloride. So the answer should be anhydrous copper 2. Can be identified by use of anhydrous copper 2 sulfate. So the answer is what? A. 16A. Anhydrous copper sulfate. A. Number 17. The phenomenon whereby sodium triglyceride 4, the carried loses some of its water. When you are exposed to atmosphere and you lose your water, that means you are efflorescence in nature. Not effervescence, efflorescence. So the answer is D. Losing water. That's efflorescence. We have explained that before. Showing debris, we did something like this. Fluorescence. Absorbing water and turn to solution. And turn to solution. That means you're a deliquescent substance and you have undergone deliquescence. If you absorb water and you turn to solution, absorbing water and not turn to solution, and not turn to solution. That means you're hygroscopic. 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 Number 18. Student prepares 0.5 molar solution each of hydrochloric acid and ethanoic acid and measure their pH. So we show that what? What is the answer? I don't know. Acid has, because the guy will not dissociate completely in water. So your Mr. Victor has taught you strong acid and weak acid. So strong acid will ionize completely in water, but the weak acid will not ionize completely. They ionize partially. So the pH of ethanoic acid will be higher than that of HCl. So the answer is D. 18. D. HCl is strong acid. And if you are strong acid, your pH should be between 1 and 3. And then CH3COH is a weak acid. Weak acid. And your pH should be higher than that of the strong acid. Number 19. For which salt in the pair above, which increase most rapidly with rise in temperature, Amos has taught solubility. So luckily for us, they didn't put KClO3. That means the answer is KNO3. That's the one that is going up like that. So the answer is B. Number 19. KNO3 is going up rapidly. So it's B. It's B. Now look at sodium chloride very well. The guy is what? Is very, very insensitive to temperature change. Sodium chloride is just like constant, almost like a straight line. You can ask you the example, the following has little or no change as temperature of the solubility on the solubility when temperature is increased. That is sodium chloride is not changing at all. Number 20, ammonia. 20, ammonia, NH3 plus H2O. We have ammonium ion and water. So this guy he donated hydrogen ion to this. And when you supply hydrogen ion, then you become an acid. When you accept hydrogen ion, you become what? Base. So that's H3O plus acts as an acid. Is a proton donor. Donated proton. Proton donor is an acid. Define proton donor as an acid. Proton donor acid. So you also define ammonia as proton acceptor base. Number 21. 4 grams of a sodium hydroxide in 250. Number 20, it will be reduced from the reaction above that. A redox reaction has occurred, no. H3O has an oxidizing, no. So that one is a C. H3O plus acts as an acid. 21, 4 grams of a sodium hydroxide in 250 cl solution contains 1.8. So number of moles is CV 1000 mass over molar mass. I can say concentration. Concentration formula and solubility formula, they are the same thing. 1000 m over mv. That's it. 1000 m over mv. So 1000, the mass they gave us, how much mass? 4 grams. What compound did they mention? So at 40. How much volume? 250. So you have 0, 0, 4 cancel 4, 0, 0, that's 0.4, Abby. 0.4 mole per dm cube. 0.4 mole per dm cube. I said, the question is not that difficult. If you are a smart person, no matter what. 2. Look at the electrolysis of a salt. When you find charge, electrolysis mass is AIT by EF. What are we looking for now? E. So I have MEF is AIT. Our inner words, AIT by MEF. That they gave us 65. How much current is flowing? 0.5. What's your T? 32 minutes, 10 seconds, I'll be 32 times 60 plus 10. Convert the time to seconds. Then the mass that they give us is 325 times 96,500. So 65 times 0.5. That's 1920, 1930 over 0.325 times 96,400. Find answer, what do you get? 2. 2. Number 23. Three following reactions occur at the anode. Of a very, look at that word, very dilute. And they mention anode. Sodium chloride will undergo ionization. And then you have sodium, you have chloride minus. And then we have water also. Water will give us hydrogen ion plus OH. They mention anode. So these two guys will go to the anode. They will go to the anode. And what they mention, very dilute. OH will be discharged. So let me see the one they wrote. OH and OH will undergo what? Oxidation. Oxidation is electron loss. So the answer is A. They will not write it the way you are expecting. But OH will undergo oxidation. Electron loss means you subtract 1. You subtract. So the answer is A. We will move on to number 24. Upset reaction. From data above, we can deduce that the most powerful reducing agent, what they give us is standard reduction potential. The smaller your standard reduction potential, the smaller your standard reduction potential, comma, the higher your oxidizing quality. 1 × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10⁻⁷ × 10 they are your oxidizing quality. So you go and look for all of them. The one that has the smallest reduction. So how do you know it's reduction potential? Because they are adding. Reduction is electron gain. Electron gain. So the one that has the lowest value there is barium. So that's why C, barium. Barium is the most powerful. Did they say reducing agent? Yeah, reducing agent. Yeah, the reducing agent. Reducing agents. What's reduction? If you are reducing agent, what do you undergo? Reducing agent quality. What did I write here before? I think that should be oxidizing. In brackets, reducing agents. I wanted to, I don't want to confuse them. Yeah, your oxidation. I think that will be better so I don't get confused. Oxidation quality. And that's reducing agent. Because if you undergo oxidation, you are first class. That's it. So the one that has the smallest value there is barium. 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 So in example, just look at the smallest negative value. You know, barium. 25. So that's is barium. C. 25. The union acid of HOCl. We did that one yesterday. Also chlorate 1 acid. Hydrogen are 1. Oxygen are X. Chlorine are -1. Abi? What the chlorine are looking for? So oxygen -2 then. Plus X. So we are -1 plus X equals 0. So that will be +1. So that means it's going to be also chlorate 1. Then we now look for the second one, HClO3. So it's chlorine. So we're going to have hydrogen 1, chlorine X, then you have -2 times 3. So 1 plus X -6 equals 0. X -5 is 0. So what's your X now? +5. So the other one will be 1 plus 1 plus 5 plus 7. HClO4. Hydrogen is 1, chlorine is X, -2 times 4 equals 0. So 1 plus X -8 is 0. X is +7. Okay, so we go to 26. A reaction that takes place spontaneously is the one where delta G. Now, delta J is delta H, and I say delta X. Now, for it to be spontaneous, delta G, for it to be spontaneous, delta G must be what? Less than 0. So if you pick D, you are wrong. Because some of you will pick that D. And if you pick A, you are wrong. That's equilibrium. Now, there's no delta G less than. Don't say the answer is not there. You now go and look for the one that can promote that negative value. Number 1, delta S less than 0. Now, if your delta S is less than 0, that means it will not become negative. Delta S less than, look at the board, though. You have to know mass. If this one is less than 0, that means it will be negative. Then the mass, what is minus minus? So that's wrong. To get negative results. So that means delta S must be positive. Very important. And then delta H should be less than T delta X. Okay, that's what they wrote. So if this one is, let's say this one is 2. Is it delta H less than T delta S? Let's say this one is 10. I'm just giving an example. Class, what is 2 minus 10? And so that's correct. I mean, the answer is well C. So it's not every time you'll be looking for delta G less than, they will not give you that. But if this one here is less than this one, then the result will be negative. If delta H less than T delta X, the result will be negative. 27. So what is one we are doing? Go through them again and again and again. In case it comes out, you can't solve that. You should be able to solve them. 27. The standard enthalpies of formation of CO2, water, and CO are this. What is the standard enthalpy for the reaction? Delta H, 8 content of the product minus 1 reactant. For the product, what and what make up the product? CO2 and what? Hydrogen. So I'm going to use only the CO2, right? What is the value for the CO2? Minus 394. Then the reactant, all the things on the left, that's Mr. What? CO and Mr. What? Water. Mr. CO, now how much? Minus 110. Thank you, dear. What of the Mr. Water? 242. We have 394 plus what? Minus 352. Minus 394 plus what? 352. Combine it to what you get? 142 kilojoule per mole. 28. Ten grams of a solid is in equilibrium with its own vapor. 10 grams of a solid is in equilibrium with its own vapor. When 1 gram of a small amount of solid is added, the vapor pressure remains the same. Drops, increases by 1%, increases by 99%. Now, introducing a small amount of solid into a vapor that is saturated has no effect on the vapor pressure. So the answer is A. It remains the same because the guy is solid. Impurities or little adding few amounts of solid into a vapor at equilibrium does not affect the vapor pressure. It doesn't affect the vapor pressure. Blessing, are you sleeping? 29. The diagram above of S represent the energy profile for the homogeneous gaseous reaction. Should the following conditions produce curve Y for the same reaction? The diagram above curve S represent, where is the curve S? And then the energy profile for a homogeneous gaseous reaction. The following conditions will produce curve Y for the same reaction. Well, the diagram is not correct, but the answer is they are all talking about catalysis. So that's why we just be C. But we didn't draw it well. The diagram will have been like this. This is X. And then this one is a Y. So that they didn't draw it well. So it's all about bringing down the activation energy. That's the effect of catalyst addition, catalysis. So diagram is wrong, but never mind. Catalysis. 30. Sodium chloride plus HO4 gives us HCl plus sodium hydrogen sulfate. Yeah, Mr. Victor taught you preparation of HCl. Now, there are so many definitions for what? For oxidation and reduction. Of course, it will be very absurd for people to say H2O4 behave as a strong acid. No. There's no base there, so I'm not going to have any acid. There's no acid. So if you pick A, you are wrong. A good solvent. What is a solvent? What solvent? A dehydrating agent. Where is the water is removing? So that's oxidizing. So how do we know? Because it supplies hydrogen. I mean, is supply is remove remove electropositive metal. Give us a strong as an oxidizing agent. That's what it does. One hydrogen was removed and then sodium replaces it. Number, okay, let's do 31 to 50 quickly. 2 minutes. 31 to 50 quickly. You can even use 5 minutes because there's no calculation. So 5 minutes. When you don't know, skip it. Okay, let's quickly go through. Should be true. There's no calculation in all this one. So the following gases can be dry with concentrated H2O4. We don't dry H2O4 by using ammonia. We don't dry ammonia. So the answer is SO2. For the 31, SO2. If you don't want to dry, you don't want to use H2O4, you can use what they call activated charcoal. For SO2, SO2 is very convenient. So that's D, SO2. 32. So the following salt we produce is metal. We've done this many times. Metal, oxygen, and NO2. I gave you the table that time. Every time we're giving you potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, hydrogen, copper, silver, gold. I'm saying that these two guys, their nitrate will give us KNO2 plus oxygen. So we've given you before. Then from here to Mr. Lead nitrate is the Olorioko there. The guy is unstable. So he give us lead oxide. Whatever happened to lead, happened to all the remaining guys, NO2 plus oxygen. So we have 2 here, we have 2, we have 4. You know, and all these guys here, Shell Mr. Silver, they give us only metal, only the metal, silver. These have been coming every time. So a very serious student should not forget this. You can balance it on your own. 2, 2, 2. So the following metal, oxygen, and NO2. Naked is sleeping. Metal, oxygen, and NO2. So that's silver to 5. That's A. Okay. 33. An experiment produces a gaseous mixture of carbon dioxide and carbon dioxide. The two of them were produced at the same time. In order to obtain pure CO, don't forget that CO2 will always dissolve in what? Alkalis. CO2 will dissolve in lime water, slake lime, and form, a salt. So the only thing you can do to remove the CO2, if you have CO2 and CO, what you have to do is to pass the two of them into what? Sodium hydroxide or calcium hydroxide. So this guy will not be trapped. You now have your CO. So the answer is what now? C. Put them through sodium hydroxide. Number 34. The following is the property of ionic chloride. Anything ionic, number one, they have very, very high melting point, high boiling point. They can conduct electricity at molten state and all that. And they can be composed by heat. That's not true. They have with aqueous silver nitrate to give you a white precipitate. That's true. We insoluble in excess ammonia. That's true. They explode when in contact with dry ammonia. And lie. They have with concrete reservoir to give white films of chlorine gas. No. They have with concrete reservoir to give hydrogen chloride. So the answer is what class? B. And you can even write examples on your own. That was the example I gave yesterday under double decomposition. Those who are in class, where the following can be used to prepare insoluble salts. I gave yesterday. And what reaction did I give you? Silver nitrate plus what? Sodium chloride. What are you going to have? Silver chloride plus sodium nitrates. This white precipitate. White precipitate insoluble in HNO3, soluble in what? Ammonia. So that's why it's B. 35. When dilute aqueous solution of lead 2 nitrate and potassium bromide are mixed, it is observed the product of this reaction are. Don't be afraid to write the equation. What do you have? Lead nitrates. Okay, maybe I should write everything for you. Lead nitrate and what? And potassium what? KPR. What is going to happen? Exchange of wives. This one come here, you come here. I'm going to have lead bromide. Lead bromide. PVB. Okay, because I write there is no need. Lead bromide. So what? KNO3. Anything nitrate in this word, they are soluble in water. They are what class? Soluble and soluble. Anything nitrates, anything potassium, So this is the precipitate you are going to have. White precipitate. So they're asking for to give you the reactions. The product of this reaction are PBO, lead bromide, bromine plus the, waiting me all this one. PBO, KBr. So the answer is DRV, lead bromide, and KNO3 camera splits. So don't be afraid. Write the equation. Number what now? Mr. Alloy, Mr. Amon, what has taught you, Victor? It's contain copper and tin. So that's E, copper and tin. 37, copper metal will react with conc, HNO3 to give us what? Option D, concentrate NO2 and water. When something is not concentrated, they are going to have NO. You have NO. So it's D. 37 is D. That means the active reducing agent in the blast furnace for the extraction of iron. Look at that. You have been taught ametite and all that. Now, carbon to break down into two. You compose, you're going to have calcium oxide and what's CO2. The calcium oxide is the one that will react with the ethylene impurity. What's the ethylene impurity? Silicon oxide. So that calcium oxide react with the ethylene impurity. What would that give us? Calcium trisilicate 4. Slag. Then the CO2. When the CO2 is trying to escape, the CO2 will now react with hot coke. That will not give us CO. So this guy is the active agent. So the CO now will not react with Fe22O3. I now have iron plus CO2 3. So the answer is carbon dioxide. Not cocoa. Not carbon dioxide. The answer is C. Carbon dioxide. Take note of all the answers so that in case you see that in the exam, you can get them. Number 39. Aluminum oxide plus 3 molecular of oxygen forgive us aluminum sulfate and water. I remember this. Can you see? The guy has both acidic and what? Property. This amphoteric. So that is B, amphoteric. The two functional group in the compound above, there's NH2. NH2 is amine or amine, and then we have COH, which is what? Acid. So that is acid and amine. And that is B. The fraction of crude oil called jet fuel is what? Kerosene. Kerosene is called jet fuel. Kerosene is jet fuel. Let's number from the left. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So the answer will be what? 2, 4, 7, hexane. The answer is D. I don't know if we got that. You shouldn't be missing me anymore. Number 3. It is not desirable to use lead tetraethyl as antimony. Someone should work acquire media. It is not desirable to use lead tetraethyl as an anti-knock agent because we have discussed the danger of lead poison. So A, it is expensive, no? Or pollution inferred from the exhaust fumes. That's the answer. The answer is B. It will contain lead. And lead is very, very dangerous. We call it heavy metal. Lead can kill. That was a year, I think it was 2 years ago. In most of the year. One family, please quiet and listen. One family, they are living in a shop. I think there's a shop here. They now close their shop. They put on their generator. So the generator is inside where they are living. Yes, with all the films and everything. I think it was last year or 2 years ago. In the morning, the next day, all of them 4, they are dead. It was in news. Why? It is not the CO that even shocked them, but the lead poison from the exhaust fumes. So many of you that are always having generator, make sure it is not directly at the back of your door. You can be shocked to death in the night and you don't know. So it's dangerous. The 4 of them dead. They were trying to preserve generator, but their life could not be preserved. Instead of them to put the generator outside, they put it inside. That foolishness. They all died. Pastor. 44. The carbon atom on 19. Anything arcane, they are sp3 hybridized. So the answer is what? No. The answer is what? Okay. Thank you, sir. Okay. Number 45. Catalytic hydrogenation of benzene. It's almost a third time. That question is repeated. So even if you don't know organic, if you miss that one again. Cyclohexane. Number 46. Look at them. What is the name of that first compound? The name. Ethyl ethanate. What's the result? You have 4 carbon. Nucleic acid. So how many carbon do we have on the left? 1, 2, 3, 4. How many carbon on the right? 1, 2, 3, 4. How many hydrogen on the left? 4, 5, 8. How many hydrogen on the right? 8. How many oxygen on the left? So we have the same number of atoms. That means we are what? Isomers. And that's A. 47. Palm wine turns sour. Palm wine contains initially ethanol. It turns sour because it will have been oxidized to what? Ethanol. D. Function of the copper 2 sulfate. Can you see that? That's what's okay. I've not been taught ethyne. Ethyne. I think you were taught it. And so ethyne is produced by adding water to calcium carbide. The reaction is highly exothermic. That's why they have to put sand at the base of the bottom, the explosion of the round bottom flask. And then in that preparation, we need what? Copper sulfate to trap the impurity. The impurity that phosphine or arsine. These are the impurities. So the answer is absorb phosphine impurity. So that's it. So the copper sulfate. So the answer is B. 9. Should the following represent saponification? That's the product of producing soap. It is called alkaline hydrolysis and oil. Reaction of carboxylic acid with sodium hydroxide, no. Reaction of alkanoate with acid, no. Reaction of alkanoate with sodium hydroxide. The answer is D. Saponification. How to produce soap in the industry. Now, we are going to be taught very soon. Now, we have hard soap and soft soap. Hard soap, they contain sodium hydroxide. Whereas soft soap, they contain what? Potassium hydroxide. Then when you finish, there's a guy called glycerol that's always in soap. It makes it to become oily. So there's a process of removing the glycerol from the soap. That process is called sorting out. It's called what? Yeah, sorting out. So sorting out will help you to remove glycerol from soap. And that involve the use of concentrated sodium chloride. You add brine, call it brine. You add brine to remove that. Number 50. The covalent test for alkanoic acid, organic quantitative analysis is the A. Turning on wet blue, little infrared. No. That is the normal test for all acids. So you cannot use that one. This is not conformity test. That's binary test. So A is wrong. Reaction with alkanol to form esters. What? That is a good reaction, but that's not a test. Reaction with sodium hydroxide to form salt and water. No. Reaction with aqueous sodium carbonate to liberate a gas which don't let water make a yes. So that's like D. Let's go to 1 to 10 now. To 10. So I have a guest who has been waiting for almost 2 hours. So please, when she come now, just allow her to talk, even with a few minutes. So you can benefit from one or two things she will say. Let's not interrupt her. Then number 10 is 23892 U and 23890 U. Two three five. Sorry, 92. 2392 U, 23592 U. Okay, I have again the class. Let's clap for again. Don't clap, let's go to the resting. Allow her to pass. Remove your leg. I'm so sorry. I've taken our time to have been waiting since. Well, yes. Okay, you are in Adams. Just tell us the school you went to, the course you study, and then few days to JAMB. That's why we are rushing. You can see you went through this. Or anyway, few things for you can still remember and that can inspire them. Let's clap for her. Yeah, very brave. We don't have time. Clap now. You don't want to clap. Yeah.
Hello, everybody. Good afternoon. Okay, so I think about 7 years ago, I was in Adams College. Like, yes, I think seated maybe front because I'm always in the front. I have to listen to what Mr. Adams is always saying. So I got into photo, graduated with a 2-1 biotechnology. So everything Mr. Adams is saying now, please take it very serious because, and I love what Mr. Adams, what he always do because he tries to not only the academic aspects, he also helps us like skills and stuff like that. So, and he's been asking me like, okay, when will you come and, because those days when I was seated here, like, do you guys, some other persons came and, come and give us their own pep talk and all. Maybe in the next 4 years, you guys will be here too to give your own pep talk. So just here to say a few things. I've been waiting, like he said. So just want to say a few things, then just be on my way.
Yes.
So
Number one.
number one, Mr. Adams is always saying this thing, the God factor. So it really helps, God factor. And let me just say some things. Hold on, please. Okay, so I just want to just pinpoint some aspect and just move on. So when we say the God factor, most of us here were in, I'll call it open relationship. You know what open relationship means? Like you're in a relationship with God and also a relationship with, you know, some other of our guys. You know what I mean? We're all adults, most of us. So it's not going to benefit us. Now you guys are preparing for your exams. By God's grace, everybody get admission. You guys are preparing for your exams. And I feel everybody should take the God factor seriously now because everybody's putting their efforts to. But the thing that, separates you from the other person is the God factor. Because I remember those days, some of us, we didn't get admission. I know I was here in 2017 and also 2018. I didn't get admission in 2017 and I got in 2018. So when time is right, right? So the God factor. And I didn't want this to be like a spiritual talk. I just wanted to just, brush up on some things and just leave. But I don't know, for some reason, the Holy Spirit was like, I should just say some things based on the scriptures to just help. I don't know who might be going through some things now that really need to, go back, pray, and see the wonders of God. So I'm just going to go to James 4:3.
Don't give enough time. Just you have 2 minutes more. Just give them general thought because we have to leave here very soon. Just give them general things. Use your life as a case study. When you were in football, what did you benefit? Or that's something that affected you, and that's something you want them to avoid. You understand?
No.
No time.
Okay, so just quickly, James 4:3.
Yeah.
Ye ask and receive not, because ye ask and miss, that ye may consume it upon your lust. That's KJV version. So what does that mean? Sometimes now, most of us now, we're asking for admission from God. So I will go to school and leave our parents' house. Mom is disturbing. Let me just go and just be on my own. But when you ask and miss, you might not get it. So what am I saying? Change your priorities. Like, change the reason why you want to go to school. You want to go to school because you want to be better, right? You want to be good. You want to make your parents proud. When I entered school, year one, there's all these things they used to do in year one. I did not really go to any of them, but still, I think I still have an idea. Bonfire night, freshers night, all those stuffs. I did not really go to any of them. But please be very careful, because those nights are the nights that cultists, like for girls, beautiful girls, cultists are always there. Like, I graduated from Futo. The cultism there is not really maybe as high as maybe Uniben or other schools that some of my friends went to, but you still know they are there. And all those nights are the night that they wait for year one, because they know you're a fresher, you don't really know much about the school and stuff like that. So they always go there to, hunt for girls and also boys. I wouldn't say one gender, also boys. So please, we should be very careful, when going for those activities. To me, I'll say don't even go. Just stay on your own. And when you're in school, don't just do only fellowship and leave the educational aspect, because you
Be balanced.
without works, like, you can't do anything. It's even in the Bible. So don't just keep on going for fellowship Monday to Friday, Monday to Sunday, fellowship, and you ain't studying, you ain't doing. You just carry over with your fellowship. You get. So when you go to God, you also do your own part. So you'll be able to come out successfully. Do you get? So
Yes, let's talk about biotechnology because of our time. If I study biotechnology, where can I work? That's what you study. How many years course was that?
okay, so biotech in other schools is 4 years, but I think every course in photo is
Yeah,
5 years. So right now, I'm in Mikio Industries, Mikio Healthcare. I don't know that you know me. So yeah, I'm working there in a research lab. So if you're in biotechnology, if you studied biotechnology, so it's more of research, That is medical biotechnology, genomics, proteomics, and all those stuff. But if you're working in industrial biotechnology, because I know that when you are in year 4, they will actually divide it, medical, industrial, and stuff like that. So industrial, you'll be able to work in places like Guinness, like, they produce beer.
Okay, because of our time. Now, if you have opportunity of rewriting your story, maybe to go, we're not saying you go back to JAMB class, your personal life now, what do you think you will have loved to do differently than what you have done?
Okay, I think I would have, I think I would have given God more time. Yes, that's just it, because I think most decisions are actually
You felt you
made.
made some mistake.
Yeah. I think most decisions I made were based on, sometimes we'll do our normal carnal minds. You don't wait for God to speak first. So you just be like, let me do this thing. This thing will benefit me. Do you get? So you don't wait for God to talk first. So I feel I'll listen to God more, like to have a more
10 seconds.
better
Let's say these are your
relationship.
younger ones now, and they are going to university in the next 3 weeks. They want to write JAMB. What's the final advice? 10 seconds.
Everything you are doing, put God first. And don't look at anybody. You get? Because you might be saying this person did this thing and she got away with it. For example, she's this girl, she's always going to parties and her life is okay. She's living fine. And you go one day and you have the worst experience ever. So everybody is not the same. Everybody has a generation, right? So we're from different bloodlines. So just be careful.
So in your biotechnology class, do you have females in photo biotechnology class?
Yeah,
What is the
yeah.
ratio like? Is it a balanced class? In nursing, we have more of female than male. In engineering, we have more of male than female. What do you have in biotech? Is it combination of almost balanced number?
Okay. In biotech, I should say they are almost balanced. Yes, they're almost balanced. But maybe in courses like maybe maths, I think maybe there are more of males.
After 5 years in biotech, what is it? Is it PSC or BTech?
Okay, BTech in photo, BTech, yes, BTech.
BTech.
Yeah.
So, ladies and gentlemen, this is okay. We don't have time. I will have never to spend. Right. John will bring you, come and talk more. But I know you have a lot of points there, but we have exam is 2 weeks' time. So we don't want you to spend much time. Let's clap for her. Let's clap for her. Clap for her. We want to pass your JAMB very well. Yes, I'm sorry on the behalf of the school. She has been waiting. She has so many things to tell you, but I have to rush her because we have a lot of things to do. Okay, I'm sorry. Okay, so we will rush through the question because of our time. Question 1. Yeah, she did biotech photo. Some of you are in medical classes and you are thinking of, I don't want to do medicine. Yes, there are some other things you can do. I don't want blood. There are other things you can do that can still give you joy. And biotech is one of them. Biotech. We don't have much time. And even after your JAMB, you can still change your school or your course. It doesn't matter. The dissolution of common salt in water is a physical change because the salt. Engineering student, please, no noise again. When you dissolve salt in water, they say it's a physical change. Why? Physical change, no new product is formed. And what you have before, you can still get it back. For example, ice block, melting of ice block is physical change. Ice block turned to water. Water can still turn to ice block. The salt can be obtained by crystallization. Solution of common salt in water is a physical change because the salt can be obtained by crystallization. B, the salt can be recovered by the evaporation of the water. That's correct. So this is B. I don't want A, I want B. Because the water will disappear and then you can have the salt left. We're not interested in the purity, so I may not be interested in A. Number 2. Number 2. So the following substance is a mixture. All alloys are mixture. So that's a bonus. Ethanol is a compound. Salt powder is an element. Distilled water is a compound. So bones contain copper and tin. 3. How many moles? Number 3. How many moles of oxygen molecules will be produced from the conjugate of potassium? You have to know how to write formula. Triacylchloride 5. So you're going to have KCl, 3 oxygen molecule. You have 2 here, Abby? 2 here. 2.45 moles. So 2 moles here give us what? 3 moles of oxygen. How many moles are we now given? 2.5 will now give us X. So we're going to have 2X. We're going to be 7.5, are we? 2.5 times 3. So X is 2.5 times 3 all over 2. Is that 3.75? 3.75 moles. That's C. Number 4. A balanced chemical equation will be the law of conservation of mass. No energy, mass. The answer is A. 5. 25 cm and 1 atmosphere, gas occupy a volume. That is a gas law. What do you get? The answer is A. Try that on your own. No time. Everybody should know gas law now. A chemical mixture of 80 grams of oxygen and 56 grams of nitrogen has a total pressure. Now you have to find number of moles. Don't use the mass. So number of moles of oxygen. Number of moles of oxygen. That will be mass over what? Molecular mass. molecule. What's the mass they give us? How much? 80. Molecular mass, how much? What you get? Is that 2.5? Are you sure? 80 and 32. 2.5 moles. What other something was mentioned? So number of moles of nitrogen. What's the mass of the nitrogen there? What's the molar mass of nitrogen? 28. What do you get? 2. What are we looking for? Partial pressure of oxygen. E for oxygen, that will be number of moles of oxygen over total number of moles times total pressure. That's it. How much is the number of moles of oxygen? 2.5. Total number of moles, 2.5 plus 2. Total pressure, 1.8. So the answer will now be 2.5 over 4.5 times 1.8. Fourth final answer, 1. 1 atmosphere. Okay, 1 atmosphere. This one is 2.5 all over 4.5 times 1.8. Answer 1 atmosphere. Number what now? Number 7. Because some of you are looking, it's as if I'm punishing you. Oh my goodness. I've reached a level that I can't be discouraged anymore. Nothing can move me. I have some students at arts that nothing. I told them in engineering class when they were making noise, I said, I would have not taught you, but because of some people. So some of you are looking as if a punishment. That's why you don't want to get the question. It's like you're tired. Adams is stressing us, wasting our money. When it comes above, representing the behavior of 1 mole of an ideal gas, what's the answer? IV, that's the answer. D. Because they put 1 mole there. By 8, for iodine crystal to sublime on eating. Please, can I have audience? Please, can you please stop noise in my class? Please, I beg you. For iodine crystals to sublime on eating, the molecules must acquire energies A less than the force of attraction, no. Equal to the force of attraction is solid, no. That has to be greater. So the answer is D. Number 9. An element E has electron configuration 1s2, 2s2, 2p6, 3s2, 3p5. That's 285. I mean, the guy is in group 5. The reaction of E with halogen. Don't forget, halogen, like this is phosphorus self. We have PCl3. Have you seen this one before? And what? PCl5. That's it too. Let me go have ES3 and what? Answer is A. Then last one, 10. Because those guys, they have the same atomic number, but different mass number. They are called isotopes. But if they have the same mass number, they are called what? Isobars. These isotopes. What if they have the same number of neutrons? Same neutron, isotone. Same neutrons, isotones. Same atomic number or number of proton, isotopes. Same mass number, isobar. So we stop here.